Okay, welcome back. Can we continue? Kindly thumbs up, please. Okay. Miss Magnolia, can you just check the Google Classroom? I already sent an invitation. Okay, shall we continue? Dito na ba si Sir Dennis, Sir Richard, Sir Jovito? Okay. Miss Magnolia? Okay. By the way, Ma'am Magnolia, kindly check, just to check, as I said earlier. Nasa ko na. I've sent already invitation for in the Google Classroom. Okay, so we have here another problem. Two trains. Wait. Okay, so we have here, let me check the recording. Okay, we have here two trains are running in the same direction. They are parallel in tracks. The trains are 85 meters and 65 meters respectively, as you can see in the drawing. You have 85 and then 65. The distance between them is 210 meters. The first train is traveling at 120 kph, while the other one is 240 kph. You can see here the conversion. And in other words, for 120 kph, you have 33.33 meter per second, and 240 is 66.67 kph. Make it quick. 1,000 meters, 1 kilometer, and then 1 hour is 3,600 seconds. Or 1 hour is 60 minutes, 1 minute is 60 seconds. So you have 3,600 seconds for 1 hour. In other words, you can have equivalent value of 33.33 meter per second for a 120 kph. Okay. First question. Determine the time required for the front end of the second train to reach the tail end of the first train. Okay. This front just reach the tail end of the second. Okay. Then the other one, determine the total distance traveled by the second train from the initial position when it has completely overtaken the first train. Okay. This one is completely overtaken the first train. Then the letter number 3, determine the distance traveled by the first train. This is the first train from the initial position until both ends of the two trains abreast each other. Both ends abreast, meaning they're just on the same level. So you can see here the time required for the front end of the second train, this one, will just reach the tail of the first train. So in the drawing, this is the second train, this is B, it will just enough to reach the tail end of the first train. This is train A of first train, train B. As it moves going here with this rate, 33.33 meter per second, this one is much bigger, so obviously that will reach the first train. Until it reaches here, the question is to compute the time required for the front of the second train to reach to the tail end of the first train. What is the time required to travel to this particular distance that it reaches the tail end of the first train on the train A? Okay, So we can have the distance, this distance SB. As you can see here, virtually we can see it, this distance SB from here going here is just equal to 210. Okay. Okay. This is 210 plus 85. So this is now the distance. Okay. 210 plus 85. And then this one traveled up to here. When you travel up to here, it is just like SA. What is SA? It's just 33 times T. And then if you're going to subtract this 85, that makes sense for the SB. Okay, again, this distance from here going here is 210. Distance from here to here is 85. Distance from here going here is SA. Now we subtract this 85, that makes the distance for SB. So that's why we have this equation. What is SA? As I said earlier, it is just 33.33 multiplied by time, or the velocity multiplied by the time which we are going to compute. So if we have this one, T could be easily computed. It's 6.3 seconds. Okay. Next question, activity for your activity. Okay. The next activity, I want you to visit. This is similar, okay? Similar concept. Just have to do with this kind of approach. The second question is to compute what will be the total distance traveled by the second train from the initial position, second train or train A. Okay. So from the initial position when it has completely overtaken the first train. So this one could completely overtake up to here. Okay. So consider if this one will go like here. That is for second question. Number third question, determine the distance traveled by the first train from the initial position until both ends of the two trains are breast each other. In other words, for number three, these two trains have the same here, okay? They are the same. Okay? So I want you to visit the classroom. Okay, I want you to visit the classroom and answer that two questions. Okay, wait. As you can see here, week 5 activity 2. Okay, the figure is complete there. So what you just need to do is just to calculate this two questions. Okay, Miss Magnolia, let me check if you. Yeah, I think okay, you accepted already. So you can now check the activity. Week 5 activity 2, just click this link and then you can answer the question. Okay, and then once you have to answer the question, you can hand it or turn in. Okay, you may start now. I'll give you for this two questions, question number 2 and number 3, I'll give you 10 minutes. Okay, so this second question, we're going to determine the total distance traveled by the second train. This is train B from the initial position when it has complete overtaken the first train. So the figure will be like this. So this will now be the second train, or the train B. This is possible because the velocity of the train B is 66.67, whereas the first train is only 33.33 meter per second. So the question is to compute the total distance traveled by the train B, or what is SB? As you can see here, SB, this distance 210 plus 85 plus SA plus 65 again. Okay, so we can have this SB is equal to 210. You have 210, you have 85, and then from here going to here is SA, which is just equal to 33.33 meter per second multiplied by T. And then add this 65 to make it the total distance traveled of SB. Okay, but then by here, SB is 66.67 T, and then SA is 33.33 T. We can compute T. If we have T, we can therefore compute SB because it is just equal to 66.67 times T with it, which is 10.8. In other words, SE is A, or I should say SB, we are looking for SB, is equal to 720 meters. Okay, who got the correct answer? 720 meters. Anyone got the correct answer? We'll check. We'll check from here. Okay. Just checking from the Google forms how many are able to get the correct answer. 719 or 720 is correct. Yeah, 294.97 or 295. Yeah, that's correct. There's also 720 meter. Yeah, it's correct. Oh, actually, the three got the correct answers. Okay, it's very good. Okay, so same question. That is the first train. When the first train will be will reach, both ends are abreast each other, so they are in this appearance. They reach in the same level or same distance, the same point I should say. So SB is just equal to 210 plus 85 plus SA. Okay, 210, 85, and then SA. We can compute the value of T again. Thus, we can compute the distance of A, or the first train, which is equal to 295 meter. Okay, so is it clear now? We can move to curvilinear translation. Okay, good. So, curvilinear translation, mostly for projectile. So, projectile, you have a velocity tangent. The velocity is tangent to a curve, meaning just at one point. You have this v sub 0 at a certain angle, theta. And then every point has its velocity. Okay, so the question here is what would be the final velocity at a certain distance, or after several period of time, or what would be the highest elevation of the curve. One thing that we have to take note is the relationship between rectilinear and then curvilinear. Remember, in rectilinear translation, we only have this equation. Okay, for example, this one, in terms of velocity. So in terms of velocity, if we are going to take Vx or Vy, I should say, For Vy, there is the presence of acceleration. Okay. But for X or the Vx or the horizontal component do not have the presence of acceleration, meaning it's constant. Why? What do you think that there's acceleration? Right? What do you think that there's acceleration in the vertical component? That acceleration stands for what? It stands for gravitational acceleration. Okay, so if you have this projectile, so here is your velocity, for example, VO. This one is your VOX, or the horizontal component of this VO, and this one is VOY. VOY, there's additional, or the presence of the gravitational acceleration. Obviously, G here will stand for the acceleration, which is negative. Okay, it would be negative. Okay, so we have here Vx, you have here AX, or for X component, here acceleration is 0, okay? Because here it's constantly moving to the right, for there is no change in the velocity in X component. But for vertical component, there is a change because of the gravitational acceleration. That's why the Vx, or the horizontal component in the projectile, is only this one. Whereas the vertical component, there is a negative G, because the normal direction of acceleration, of gravitational acceleration, or G, is going down. Since the direction of the vertical component based from this initial velocity is going up, so meaning this one is in a negative value, it's in opposing direction. That's why Vy is Vu sine theta minus GT, G, okay? 9.81. That's why it's negative. Why is sine? If this is your theta, obviously VOY is in the opposite. This is VOY. Opposite of the theta is it's sine. VOX, it's the adjacent, which means it's cosine. So this is the relationship. Now, if you're going to talk about distance, again, for distance, you just have to multiply the horizontal component of the initial velocity with that of time, and then you can have distance. There's no presence of acceleration. Acceleration is constant. Whereas here, for vertical distance, or y, I should say here y, it's y. There's du sine theta multiplied by time, and then there's the negative g. Okay, it's negative g. In rectilinear, it's a, but it's if it in projectile or in curvilinear translation, it's g. Okay, it's gravitational acceleration. Some formula that you need to memorize to avoid derivation, especially during exam, is when there is the presence of x and y coordinates. What is this x and y coordinates? For example, if you have here a projectile, it reaches at certain point below this level, then you have here at this point, you have here x and y. Obviously, y here is below. If this is 0, 0, y is negative value. So if you have this, okay, you can use this formula. Yx tangent theta minus gx squared to vu squared cosine squared theta. Anyway, this one comes from the combination of this. Okay. And you have to compute maximum height of a projectile. Maybe here, maximum height, that is when the velocity here is horizontal, the final velocity, meaning there's no vertical velocity component for the velocity. Then that height, or the maximum height, will be calculated easily using this formula. Okay, so let us try this example. You have here a stone. Here is this man throw a stone at an angle of 60 degrees. The horizontal with the horizontal, 60 degrees with the horizontal at initial velocity. The initial velocity here is 30 meter per second. Okay. Now, after hitting level ground at the base of the hill, the stone has covered a distance of here 150 meters. The horizontal distance is 150 meters. How high is the hill? So you can make use of this formula that I have presented earlier. Okay, first, okay, what is this one? This, okay, this is formula for distance. Okay, x, as I said earlier, there is no need to add here acceleration. Okay, it is just this v cosine theta. It's actually the component of vx, or the component of the initial velocity, which is 30. Vox or Vx. And then time, x is given, and then we can compute t. But if you have to compute for y here, starting from here, okay, if this is the axis, starting from here, going down, if this is, let us say this is 0, so going down becomes negative. It's a -1, -2, in the Cartesian coordinate system. So h is negative h. Y is equal to negative h. This is the formula I presented earlier. The vertical distance by which there is a presence of this g, because in a vertical distance of a projectile, or in a curvilinear translation, there is the presence of the gravitational acceleration, which is in negative form. So we substitute it here. V initial velocity is 30 sine 60. T is 10 seconds. It's already computed here. G is 9.81. 10 is given, so we can compute H. As easy as that. So what do you need to memorize again? To remember this formula. Okay? You just have to remember all this formula. Okay? Once you have the formula, then it's easy to, especially this one, for y component and then x component. Okay, how about this one? Okay, the ball is shot at ground level at an angle of 60 degrees. It's clear, right? With the horizontal, with an initial velocity of 100 meters per second. It's 100 meters per second. With an, okay. The question is, which of the following gives the height of the ball after 2 seconds? After 2 seconds, when time is t, you can compute x, horizontal distance, this x. Because if we have this component, this horizontal component, which is just 100, since this one is adjacent to 60, cosine 60, which is already here. Okay, so Vx, or horizontal component, multiply by time, give you x. Okay, so you have your x, Vx, and then time. You can compute x. The question is to give the height of the ball after 2 seconds. Okay, maybe after 2 seconds, it's here. We don't know. So let us assume that after 2 seconds, the ball is here. Okay, or maybe here. Who knows? So we can use this formula that I mentioned earlier. We have the coordinates x and y. We are looking after y. X is given. You have theta. Everything is there. Okay, you have g, x, v, or theta. You can compute y. So here, you just need the formula. If not, you can derive it. Y, what is the distance y? Y is equal to VOY multiplied by time minus, okay, AT squared, or GT. GT, this one. Okay. 1/2 GT squared, I should say. Okay. Squared 1/2. Start here to compute for y. Okay. But it's easy to just use this formula. As I said again, this one is derived from that formula. When you have x and y coordinate, then you can use this formula. If not, you go back to this basic component or formula for the projectile. One thing that you have to take note here, again, always going to the horizontal direction, there's no acceleration. Acceleration is always zero. But in vertical direction, there is the presence of the negative g. Second question, the velocity of ball after 2 seconds. So what would be the velocity here? Okay, after 2 seconds. But first, okay, you have this V3 is the horizontal velocity. As I said again, this is just the horizontal component of this 100, which is just 100 cosine 60. And it doesn't change. If this is 50 here, this one is 50, this one is 50. It's also 50 all over. All the horizontal component along the curve or along the projectile is 50 meters per second because there is no acceleration. While for vertical component, that's the thing that you are going to compute. If at the initial velocity you have V1, what's V1 here? Or the vertical component, it's just 100 sine 60, okay? This is 0.6. We can use this formula to compute for Y. No, Y is already given earlier. It's 153.59 because it's after 2 seconds, okay? It's already here, 153.59. So it's already given, you already computed since our calculation is to compute for the velocity after 2 seconds. So you can compute V2, but V2 is just the vertical component. See, it's vertical, we just write here 2, or we can have it, so we write it here V1Y, so it should be V2Y, so this one should be V2X. So just too easy to distinguish, it's V2 meaning vertical component, V3 is horizontal component. So what is V here after 2 seconds? Let's say VF or V. So as you can see in the drawing, VF or V is just the resultant of V3 and V2. In other words, V is just the square root of the squares of V2 and V1, or V1 and V2. So you got the velocity after 2 seconds. Okay. This is velocity after 2 seconds. Third question, time it will take to hit the ground. There's also a formula of that range, or the range in a projectile. You can use this formula, V squared sine 2 theta. Again, you just have to memorize this one. Now, this one is taken also from computing S. Just have to take this one, okay? So what is R? V is 100, its initial velocity. 2 times 60, that becomes 120. G is 9.8. When you have this R, okay, you can compute T because the initial velocity, as I said again, S is just equal to V times T. V is the V, or the horizontal component, okay? And the horizontal component doesn't change. There's no acceleration in horizontal direction, only in vertical direction, okay? So from this, you can have R, V cosine theta, which is 60 multiplied by time. You can get time, which is 70.66 seconds to hit, okay? Okay, to hit the ground. There's a different, another method that you can do, but this one is much, much easy and simple. Okay, so any question about this one? If none, we'll move to another topic. Okay, this these problems are all very most common in part of the mechanics. Okay, it's always given in the board exam. Okay, we'll move. So we are now on shear and bending moment and beams. This is also very important in the board exam. It's always given. Even in the actual job, this one's very important to understand. So we're talking here about statically determinate beams. So we'll be discussing here determinate beams. And afterwards, the later section, we are going to discuss also indeterminate beams. So what are determinate beams? So you just have to check these relationships. Reactions, equations. How many equations do we have? Okay. Equilibrium equations, I'm referring to. Summation of forces vertical, summation of forces horizontal, and summation of moment. So there are 1, 2, 3 equations available for determinate beams. Okay, for simple beam, obviously, you have R reactions is 3, because here it's roller, you have here one reaction, you have also one reaction here, and another here also. So 3 reactions, the equations is 3, so this one is determinate. R is equal to the equation. For cantilever beam, it's also the same. You have here 1, you have 2, and then you have 3. Okay, the same. It's also determinate beams. When R is equal to, and the reaction is equal to equations, then it's a determinate beam. But there are some also the way method to determine the determinacy, level of determinacy, which I'm not going to going further about it. It's not so very significant for the purpose of the board exam. Okay, this one just to check simply if the beam is determinate or indeterminate. Now, one thing that you have to understand in the sign convention of the beam is very important, as always, when you're going to analyze the beam, get the moment at certain distance of the beam, what would be the orientation of the reactive forces at the cutting section. So if you have to cut, for example, this is a beam, you have to cut it here, so it will be shown in this manner. So this is the positive direction. At the right side, it's going up. Here, it's going down. And here, for moment, the left side, this one is the positive. Here, it's positive. This is the direction of the positive moment. Okay? It's very important because if you, let's say you have your beam, simply supported beam. Now, if you're going to cut at the section at a certain distance x, okay? Now, how you're going to show this one here? If you're going to show at A, so what is your, this is the cutting section. You have here R. So this one should be your moment, which is positive, and then this one should be your shear, which is positive. This one, all the positive direction. Okay, opposing in that direction shall be negative. To make a universal consideration of the convention that will be easier for us, for you to remember, then you have to follow this one. Okay, another rule, especially in the shear moment diagram in the beams. So general rule, 0 degree and for 0 degree and first degree, what are the 0 degree? Okay, 0 degree, first degree. Okay, triangular load is on a first degree. Okay, this uniform load is the beam is 0 degree. But from 0 degree, after this one, when you are going to plot the shear, that becomes first degree. And in the moment, that becomes second degree. Okay, so that would be the sequence. Okay. Now, for in plotting the shear moment diagram for 0 degree and first degree, you just have to connect the values by a line. Okay. But for 2 or more, you have to consider this load. When the shear is increasing, for example, this is your shear diagram. This is increasing. This is 0 to a certain shear, positive shear, or maybe let's say 10 kilonewton. So meaning this is increasing. So for shear, this will be your moment diagram. If your shear is increasing like that, your moment diagram is this one. But if your shear is decreasing, your moment diagram is this one. One thing that you have to remember, okay? But that becomes opposite when you have in okay, I will see, share it later in some other instances. Okay. Maximum moment occurs where shear is zero. When the shear is zero, you can find the maximum moment. What else? The area of shear diagram denotes a value of moment, meaning if you are going to calculate the area of the shear diagram, that becomes the value of your moment. Well, the point of your moment is zero is, what's that? I could not read it. It's the point of inflection. Okay, what else? It will be easier for you to understand later once we have this example. Okay, so how are you going to plot this curve? Okay. Okay, so determine the maximum shear and moment and location, the point of inflection from the left. So what is the shear and moment values, which could be easily calculated using diagrams. So first, of course, you need to calculate what are the reactive elements. Here, let's say this is A, this is B. So this one is R, A, and this one is RB. You need to compute first the reactions for us to plot the diagram. Okay, first, you need to, how do you are going to calculate? You can take moment at A to compute for RB, or you can take moment at B to compute for RA. Here is already given. Okay, so let's calculate. If we take moment at A is equal to 0, we can have all forces going clockwise direction is also equal to the counterclockwise direction. So we take moment here, we take it moment here and A, so we calculate RB. So what are our clockwise direction? 5 times 20. You have here this resultant force becomes 5 times 20. And then the distance coming from here going here is just half of 20. This is equal to 10. So meaning you have here 5 times 20 times 10. Okay. What else? Clockwise direction, you have here 20 with the distance from here going here is 25. So you have plus 20 times 25. This is clockwise direction. Counterclockwise, only RB. So RB times 20. So we can compute RB. What is RB? It's actually here. This is 75. Okay. RA is 45. This one RB is RB is 75. You can try with your calculator. Let me try. Okay. 5 times 20. 5 times 20 times 10. You have 20 times 25 plus divide 20. Yeah, it's 75. Then you can take moment. You can take moment also at B. Okay, 0 to compute for RA. But if you are confident that 75 is already correct, 75 kilonewton, then you can just sum up vertical forces. Okay, so what are the vertical load, or what are the load? 5 times 20 is 100. 100 plus 20 is 120. So meaning you have 120, that 120, the total load is just equal to RA plus RB is 75. So in other words, you have RA is equal to 45. Okay. So this is just to show to you how we get RA and RB. Okay. So we can draw the I'll erase. We can now draw the diagram for us to compute the shear, maximum shear and maximum moment. Okay, so how we able to do this one? So going up, as you can see here, it's going up is 45. We calculated already earlier that RA is equal to 45, and then RB is equal to 75. 75 plus 45 is 120, which is equal to 100. This uniform load is 100, and then this also this concentrated load is 20. So you have 120 kilonewton total load. So going up is 45 for RA. You have your RA is 45. Going up here, it's 45. Now, you have here, as we already computed earlier, this is 100 kilonewton. This is just 5 times 20. Going down is 100. So if you have 45 here, you just have to deduct. Okay. Going out, for example, here is, let's say this one is VB. VB1. What is VB1? You have negative, you have 45 going up minus 100. Okay, that's why you have negative 55. Then this negative 55, take note that RB here is 75. Going up is 75, you can have this, you can get this 20. How did you get this 20? Let's say this one is VB. For example, this one is VB 2. So you have negative 55 and then plus going up. Itong RB is going up naman, is positive. Okay. Plus 75. Okay. So negative 55 plus 75 becomes 20. Okay. So you have this 20 kilonewton. Looking at here in this area, wala ditong load. Okay. There's no load here. So you just have to make this line straight. As I said earlier, you identify this point 45 and then this point is negative 55 from this calculation, and then general rule, if you have this this one is 0 degree. Okay, 0, it's here. Here is first degree. If you have first degree, you just have to connect this point going there. Okay, so that becomes just a straight line. Okay, and then if you don't have load here, straight lang to. Okay? Just straight. And then going down here, it's a load going down, so that will just make sense going at this point. So this will become your, okay, so this will become your shear diagram. How about the moment? Moment diagram. Okay. This, okay. This area, if you're going to compute, is just the value of the moment at this point. Okay. So this one should be your shear diagram and moment diagram. We calculated already earlier. We calculated earlier how to compute your shear. Now, how did you compute this 202.5? Okay. This 202.5 is just the value of this area. Okay, this area. But first, how are you going to compute this x? Okay. We have an example. I said to you earlier that you can cut this value at a certain distance of x. Okay, and then you can have here moment positive, going down is also positive. But there is a shortcut here. Okay, you can just, the shear, which is 45, is just equal to the load here. There's a load here. Okay, that's 5 kilonewton meter. 5 multiplied by x. Okay, and then therefore we can compute x is equal to 45 divided 5 is 9. Okay. So therefore, this is 9. And this side is 20 minus 9 is 11. So what is this area? How to calculate 202.5? Let's say this one is moment A, this one is A, this is B, and then let's say this one is C. Okay. So how to compute moment C? Moment C, as I said earlier, from our general rule, that is just the area covering this shear diagram. So what is this area of triangle? It is just 1/2, okay, this side, which is the value of the shear, is 45 times this base is equal to 9. So if you have a calculator, you can try it. Okay, 45 times 9 times 0.5 or 1/2. You have 202.5. So this one is 202.5 kilonewton, or yeah, kilonewton meter. How about this 100? Let's say moment B. Okay, moment B, I'll write it here. Moment B is just equal to, first, you copy this 202.5, you copy first. Okay, that's positive. 202.5, and then this one, this area. Since this one is negative, okay, so meaning you can just deduct. Minus 1/2 of that area is 1/2, 55 times distance is 11. This is the one that we are calculating. Okay, this area, which is a negative value. It's 11. Okay. Okay, so we can calculate what's the value of this one. 202.5 minus 55 times 11 times 0.5. So it's negative 100. Okay, this negative 100. So this one should be negative 100. Okay, how we get this value 0? As you can see here, this area, what is this? Distance is 5. 5 times 20 is 100. Obviously, the value of this area is 100 kilonewton meter. Okay, this 100. And since this one is at the positive side, okay, so you have positive 100. This one is negative 100. This one is negative 100. This one is positive 100. In other words, that will have the 0. So we are just trying to identify this point. This point, you have this point, you have this point, you have this point. So you can connect now those points. Okay. And based from our rule, if this one, if the shear is decreasing, this one is decreasing, okay? This is decreasing. So you can have in this manner, this curve. This one is decreasing again from 0 to negative 55. 0 is greater than negative 55. So it's decreasing. Goes back here to this point that we traced already earlier. And then this one is horizontal, okay? Is 0 degree. So we just move this one. This is first degree already. This is first degree. You can just connect it this point. So this is your shear moment diagram. Okay, so the shear moment diagram. What is the maximum shear? Maximum shear is what? 55. Maximum moment, positive is 202.5, negative is 100. So this one is maximum moment. Location of point of inflection from left. What's the point of inflection in our rule? The point where moment is 0 is point of inflection. Okay. Where the moment is 0, here. Okay. How do we calculate this one? Are you still there? Hello, andiyan po ba kayo? Thumbs up.
Ito po, sir.
Okay. So, how can we calculate this point of inflection? Ang tinatawag na point of inflection, sinabi natin kanina, where moment is zero. Okay. Ito yung moment is zero. Okay. The moment here is zero. So, we have to identify this value of x where the moment is zero. This x. What is that point where the moment is zero? Actually, when you just cut that beam, ito yan, ano? Ito, cut natin dito. Hindi ko pala na ilagay yung calculation. This one is moment. Ang hinahanap natin is point of inflection. This one should be x, by which this moment should be equal to 0. Okay? May reaction tayo dito na, anong reaction natin? 45. Okay? This is 5 kilonewton. Laki nitong ginamit ko. 5 kilonewton per meter. Okay. Now, if we take moment here, what is this point? Let's say x. Ano? Take a moment at x. Okay. Summation moment at x is equal to 0. Ibig sabihin, dito tayo mag-iikot. Okay? Ganon ang positive natin. Okay. So, anong moment dito? First, moment, positive here. Ito, moment x. Moment x. What's next? 5. Okay? Itong 5 in this direction din, pag ganon. And distance is from here, going here, distance is x over 2. Kasi ito, from here, going here, it's x. Okay? Yun yung x na kinocompute natin na distance or the point of inflection. Okay? So you have your moment. What else? 5. Itong 5. Anong resultant dito is 5x. Okay? So it's positive kasi counterclockwise based from our convention. So it's 5x. Distance is x over 2. Okay? What else? Opa. You also have here 45 minus 45 times x is equal to 0. Ito, 0 kaya sinasabi niya. Sinasabi is, the point of inflection is when the moment is equal to 0. So, makancel dito yung x. Isang x, makancel. Isang x, makancel. So, we can compute here x. Okay? It becomes 45, magiging positive, times 2 is 90, divide 5. Okay. 90 divide 5. 90 divide 5, 18. Okay. So point of inflection is 18 meters. Okay. From here, going here is 18 meters. That's point of inflection. May isang calculation na mas madali. Okay. Kuhan nyo lang. No? Yun ang pinakamadali na pala. Okay. Naintindihan niyo ito? Is this clear? Itong point of inflection? Okay, thank you. Okay. Siguro last na to. May activity pa ako pero huwag ko lang ito. Assignment ko na lang. Bibigay ko na lang sa inyo assignment. So for this one, this is board exam type also. Ito actually madali lang to. Ano? From the figure shown, okay. From the figure shown, you have here a uniform load of 112 kilonewton meter, and then is acting downward and supported by an upward uniform load, which is 48 ito 48 kilonewton meter. These are the distances. Okay, what's the question? Kuna question. So the first question is maximum shear, and then also the moment. Okay, maximum shear and moment. Hindi ko lang hindi ko lang nailagay yung question. So the question is, first is to compute the maximum shear. So plot niyo lang yung curve na to, no? What's 48? Actually, ito 48, ano? This area is a rectangle, right? Okay, it's a rectangle. So this is 48. Itong pinaka-height niya dito is 48. Kasi 48 kilonewton per meter. 48 times 1 becomes 48. Okay? And then, how about this one? How can you get this negative 48? Okay? You can see here, 112, this is 1. This is 1.5 meter. Okay, 112. So, meron ditong pababa na you have here 112. Okay? Meron naman dito pataas din kasi nga uniform nga ito, 48 din. So, in this area, magkakaroon ng resultant force. 112 and 112 which is going down and 48 which is going up. Of course, ang mag-govern ng pababa. Okay? Ang mag-govern dito, yung parang resultant force is going down. Okay? That is just 112 minus 48 is equal to 64. Okay? It is 64. So para magkakaroon ka dyan ng rectangular load, ng direction is going down. Okay? It's going down. It is the resultant force, resultant uniform load which is going down. Okay? Ang isa, 48 going up. Ang isa naman, 112 going down. So the resultant is 64 going down. So if you have 64, and then you have here 1.5, so we can compute the total load going down. So the total load going down is just equal to 64 times 1.5. Okay, what is this? 64 times 1.5 is just simply equal to 96. Okay? 96 going down. Okay? So kung meron ka dito sa taas 48 na positive, tapos may going down na 96, obviously, here it becomes negative 48. Paano to? It is just positive 48 minus 96. Kasi nga yung 96 pababa. Kaya, negative 48 siya. This one, going up 2. The same calculation, okay? Now, going up, I should say 48 at a 2 distance 2. Okay, here. Okay, paano naman naging 48? So, this is just, meron ka dito sa baba na negative 48. Asan ba to? Ito yan, no? Negative 48. Plus, going up na 48 times 2. So, magkakaroon ka ng positive 48. Actually, this is symmetrical. So, negative 48 din dito. Okay? Negative 48. This is 0.75 and 0.75. No need to calculate. Okay? Just by looking at this one, by just having a good judgment, then you can conclude that it's 0.75. Okay? Kasi nga, ito 48, ito 48. Okay? They are the same. So, that will meet, that would intersect here at 0.75 or 1/2 of that distance. Similarly here, 48 ito, 48 ito, so 1 din ito. So, ang moment, paano pag-compute ng moment? Madali na. Kasi, ito, this area, which is triangle, is just equal to 42. Okay? What is that area? Area is, the area of the triangle is 1/2 of base times height or the altitude. If you have this triangle, ito yung altitude, yung perpendicular distance. So what is that area? It's just 1/2. Ano yung base? 1 and 0.75 is just 1.75 times height na, ano yung height? 48. Okay? So, what is that value? 1/2 times 1.75 times 48 will give us 42. Okay? Kaya 42. Actually, hinahanap lang naman dito maximum shear at maximum moment. Itong 24, makakompute natin din to kasi this is just the area, this area. Okay? 1/2 of 1 times 48 is, obviously, it's 24. But the total, it's 42. Okay? So, since this one is symmetrical, you have the same values here and the same values here. So maximum shear is obvious, 48. Maximum moment is 42. The distance of the maximum of the point of inflection, where the moment is 0, is obviously here. So 3.5. What is this 3.5? This is just 1 plus 0.75 plus 0.75, 2.5 plus 1 is 3.5. Actually, just in the middle. Okay? So, itong activity 3, bibigay ko na lang sa inyo as assignment. Okay? Andun sa kuan, nasa